When you have complex control architecture, it can be difficult and time-consuming to tune the controllers, test the results in simulation, and iterate the tuning process to find gains that meet your system requirements. In our 2014A, we introduced the Control System Tuner to speed up and simplify the process of tuning these fixed structure controllers. To demonstrate how this works, I have a DC motor modeled using Simscape blocks and two proportional integral controllers on the measured current and motor speed feedback. At 6 seconds, a disturbance is injected as an external torque on the motor. When I run the simulation, one can see that the motor is slow to react to the step input and does not reject the disturbance well. I will use the Control System Tuner to update the system gains and achieve a better result. In the Control System Tuner, I will start by going into the Tuning tab and selecting the blocks to be tuned. In this model, I need to tune the speed controller and the current controller. Next, I need to set up my tuning goals. Since I have two loops, I will set up two goals, one for the inner loop and one for the outer loop. The inner loop is designed for the purpose of disturbance rejection. This is closely related to the bandwidth of that loop. Therefore, I will select a loop-shaped goal, select the inner loop measured current, open the outer loop at the measured speed, and select an integrator loop shape because this is good for disturbance rejection, and set the crossover frequency to my desired target bandwidth of 200 Hz. The outer loop is designed to track the input. I will select a step response target goal to accomplish this. I will select the speed reference input to the measured speed output and define the time constant as 0.05 seconds. I can now observe my requirements plots and see, as expected, that I don't currently meet the requirements I set. Now that my goals and blocks are set up, I can hit the Tune button. The results are normalized such that a value less than 1 means the tuner was able to achieve the goal. With the tuning now completed, I can again observe my requirement plots and see that my requirements have been met. I can now come back to the Control System tab, store the design for future iterations, and update the blocks in my model. I can rerun the simulation and see that my new response is much faster than before, and the controller is able to quickly reject the disturbance.